Welcome, everyone, and thank you for joining us. My name is Mousseau. I'm professor of physics at Université de Montréal and scientific director of the Institut de l'Énergie Trottier at Polytechnique Montréal. I'm also co-founder and research principal at the Transition Accelerator, a pan-Canadian organization that works with others to identify and advance viable pathways to a prosperous, competitive, and net zero Canada. Today's discussion is part of our Pathway to Net Zero webinar series, where every month we highlight interesting and emerging topics related to the energy transition. And we would like to encourage you to attend our upcoming events that will focus on biofuels, dead-end pathways, and direct air capture. So keep posted. We'll have links to our upcoming webinars and courses in the chat. Given today's topic, I would particularly encourage attendees interested in the question to sign up for new course on energy modeling. This course is designed to equip leaders in government, industry, and civil society with the knowledge and tools to move your teams and Canada as a whole to net zero. Today's seminar is presented in collaboration with the Energy Modeling Hub and the Answer Create Leadership in Environmental and Digital Innovation for Sustainability program. So the Energy Modeling Hub is a structure initiated by Natural Resource Canada and led by the Institut de l'Énergie Trottier, the Institute for the Integrated Energy Systems at University of Victoria, and the School of Public Policy at University of Calgary. The EMH mission is to support timely and evidence-based policymaking towards a net zero economy by bringing together policy, energy modeling communities, as well as maintaining and providing access to comprehensive suite of robust and open source resources and modeling tools. And LEADS is an Answer Create graduate program on the themes of science leadership for global sustainability in the digital age. So now I would say let's move on to the discussion, which is really why we are here today. So we will begin today's webinar with a presentation from Dr. Erica Thompson, who is Associate Professor of Modeling for Decision Making at University College in London. This will be followed, this presentation, by a discussion between Dr. Thompson, my colleague, Dr. James Meadowcroft from the School of Public Policy and Administration at Carleton University, and also co-founder research principal at the Transition Accelerator, and myself. This webinar series, you know, if you have been following it, is mostly focused on accelerating transition. And modeling is really essential to plan properly, understand challenges, and identify the most interesting pathways. Yet, it is very easy to misuse models, especially in a field moving as fast as this one. Of course, this challenge of using models for decision-making is not limited to the field of energy. And this is why we have invited today a modeling specialist with a very critical eye to help us understand how to approach this tool. Dr. Thompson's research is centered around the use of mathematical and computational models to inform real-world decision-making. She has worked on mathematical and statistical methods for model evaluation and interpretation, as well as on fundamental philosophical question about what models outputs really mean and how we use models in tandem with expert judgment. She has a particular interest in real-world applications of modeling methods, and she has worked with humanitarian NGOs, insurance practitioners, the UK government, and many other partners. She is, I would say, that's the core of, I would say, probably what we'll be talking today. She is the author of Escape from Model Land, How Mathematical Models Can Lead Us Astray, and What We Can Do About It. This book was published by Basic Books last December. It's fascinating, and it tells us about the uses and pitfalls of models to inform decision. I should say that Erica gained a PhD in physics from Imperial College London on statistical and dynamical modeling of North Atlantic storms under climate changes. So, Erica, please, the floor is yours.
Thank you so much, Norman. It's fantastic to be here and great to see an audience like this as well. Thank you so much for the invitation. Okay, so yes, escaping from model land, that's what I'm going to talk about. So you've already said a little bit about who I am and where I'm from, but I thought I'd start by sort of situating myself a bit more clearly in this space. Okay, so next slide, please. So I began, as you said, with a PhD in North Atlantic storms. And the first thing I did during that PhD was a literature review. And I looked at what other people had found using different models about North Atlantic storms and how they would change as a result of climate change. And in the process of doing that literature review, I suppose what I realized was that there were models which said that the storm tracks would go north, they'd go south, the storms would get stronger or they'd get weaker, there'd be more of them or fewer of them, and that they didn't really even agree within their own error bars. And so that made me realize that it wasn't telling me very much at all about climate change, and it wasn't telling me very much at all about North Atlantic storms, but it was telling me a lot about the way that we make models and the way that we interpret models and the way that we think about uncertainty and the way that perhaps we'd drawn those error bars, the confidence intervals from the models in a way that wasn't perhaps totally justified by the information. And so I started thinking about, what does that mean? What do we do with it? How do we actually use the outputs of this kind of model, and how do we more generally understand what we mean by a model and what we can do with the results? And so then following that, I spent about 10 years working on a series of different projects. So one was a project with humanitarian agencies looking at how to take decisions in response to a weather forecast. Supposing you have a weather forecast saying that there's going to be a cyclone in Madagascar, what do you do, and how do you prepare? How do you deal with the uncertainty as well? Because in the trade-off for having some warning is that there's also some uncertainty about where it's going to go and how intense it's going to be and what the impact will be. And so then I also started thinking about financing and about how actually, if we're going to make decisions which have financial consequences, such as, it could be adaptation, it could be insurance, it could be the humanitarian decisions that are taken day by day and week by week. But the higher level question then is, who is financing this and what kind of structures are created to do that? And how do they know what they're committing to? Because if you're going to construct an insurance scheme or you're going to construct some sort of humanitarian scheme, you need to know what you're committing to. And the only way to be able to do that is by having a model about the future, because the future hasn't happened yet. We can't go out and measure it. The only way we have access to it is through mathematical models. And so you can see I've sort of, looked at this from a number of different directions and been thinking about it for quite a long time. And so I started thinking about writing a book to try to bring all this together. And then, of course, there was, next slide, please, a pandemic. It's been many things, but among those things for me, it's been incredibly educational about the way that we use models. It's been a case study in practice of how models are fed through to decision makers, policy makers, and how they are used in practice to not just to support decision making and inform the decision making, but also to kind of justify decisions that are made, perhaps with many other pressures around them. The models have also been used to communicate decisions and to communicate what are the key factors in a situation. If we think, for example, about the whole narrative of flattening the curve that was predominant in the early days of the pandemic. That's a very simple model, but it's one that was extremely effective at communicating some of the key factors around, what people actually needed to do in the short term. And so models, they impinged on the way that we experienced this crisis, right? They were part of the narrative, part of the debate, part of the discourse, part of also the kind of the machinery of debate, because you would see a model and say, oh, I don't think it looks like that. Maybe it looks like this instead. Or what are the assumptions that we've made there? And so I suppose I also started thinking about the ways in which those models then almost as boundary objects become so embedded in the debate that they're also framing the debate. And so I found that really a very interesting case study of this interface between the scientific world of where we go away and we make a model, and obviously in the case of pandemics, you hope never to have to apply it, but that you will. And then the policy making side, where the policymakers are coming back and saying, well, we need the information. What kind of information do we need? And there's this dialogue. It's not just the case that the modelers are coming along and throwing something over the fence to the policymakers. There's a dialogue of the policymakers saying, well, we need to know this kind of information. We want to take these kinds of decisions. Can we get that into the model? And of course, some models you can get these things in, and maybe some models you can't get a particular kind of thing into that model. And so the model also limits the debate in a way as well. And the kinds of models that you have available to you and accessible to you and in the scientific literature, again, frame the way that you're able to respond as decision makers and as policymakers. And so next slide, please. That was the context in which I was writing this book, Escape from Model Land. So I should just say a bit about what I mean by escaping from model land. And what I mean there is that model land is sort of where we are when we are inside the model, right? So you've got maybe a set of equations, or perhaps it's just a flow chart of how you think things interact with each other. And when you are sort of within the confines of that, you're inside your computer program, or you're inside that flowchart, and you, by assumption, all of the things that you've assumed are just true and everything works, and you can run your data through and you can get an output, and maybe it's incredibly complicated or maybe it's quite simple. But within the boundaries of model land, within the sort of inside the model, everything kind of works. But nobody cares, right? Nobody has any interest in what happens within the boundaries of your model, within model land, unless you make a claim that it has something to do with the real world. And so I started thinking about this jump, this conceptual leap out of model land back to the real world. How do we actually demonstrate that what we are doing in model land has any relevance, any decision relevance, any policy relevance to the real world? How do we demonstrate that it is actually useful for the purpose of informing real world decisions? And of course, this is a critical question, because anybody can go away and make a model. But what kind of quality control do we have on those models? What kind of questions do policymakers and decision makers need to be asking to assure themselves that these models are actually fit for purpose and are actually useful? So if we go on to the next slide, what I propose in the book is that there are essentially two main escape routes from model land, two exits. And one of those, I'm sure both of these are quite familiar to you already. One of those is going back and checking against data and saying, was this model any good in the past? If we've got this set of data, can we just do some statistics, or even just sort of put two pictures up together and say, does it look like it basically did the right thing in the past? Hopefully that's some kind of evidence that it will be good in the future. But we are also left to make some judgments about model quality, because maybe we don't have very much data, or maybe we think that the data that we have from the past are not going to be completely relevant in the future. For example, if the climate is changing, then the data that we have gathered previously may not be relevant in the future so much. Or if we're thinking about social systems, people change, politics change, the data that we have from the past may not be completely relevant for the future. They may not be totally useless. They're telling us something, but they're not giving us a perfect warrant that our model is going to be absolutely 100% accurate. And so if we go to the next slide, please. The way I conceptualize this, perhaps for the more technical people in the audience, would be to say that if we have a set of data and we use that to make a model, I mean, maybe you've got a bunch of points and you go to Excel and you fit a line through them, and you could choose to fit a straight line if you wanted, or you could click a different box and you could fit a curve instead of a straight line, and you maybe get a slightly better fit. But essentially what you're doing is interpolation. And if you are trying to make a prediction within the range of the data that you have previously experienced, then your model is data-driven. And as you can see, it doesn't actually make a huge amount of difference whether you fit a curve or a straight line or something more squiggly. Actually, there may be some observational uncertainty in the data, but you're kind of going to get basically the same answer. It's the model is pinned to the data within this white box, rather than being very sensitive to the functional form. Now, of course, if we skip to the next slide, if we go outside the range of that white box and we go outside of the range of the data that we have previously gathered and the conditions that we have previously experienced, then we are extrapolating, not interpolating. And of course, we know that we have to be careful in extrapolation. But the key difference is that then in extrapolation, the uncertainties, and the outputs are very much driven by the assumptions that we're making about the functional form, rather than being pinned back to the data. Obviously, there is a dependence on the data. And so I'm not saying it's a binary, you sort of suddenly flick from one to the other, but you move quite rapidly into a regime where the assumptions that you've made are at least as important as the data and possibly a lot more important. Okay, so if you skip forward again to the next slide, there's just a few examples here. So we say if we're in that data-driven regime, we might be thinking about things like ballistic motion. You hit a golf ball or throw a basketball. I can predict what the trajectory of that ball will be because we have lots of data of similar things in the past, and we can do even better if we calibrate it with the one that we've got in front of us. Things like transport scheduling probably would be primarily data-driven. Things like the weather forecast are mostly data-driven because we are mostly in the realm of things which we have previously experienced. Now, of course, extreme events do happen and the climate is changing, and so extreme events happen more often than they used to. And so we, at the edges, we are going into the assumption-driven territory where we need to be more careful. But on the majority of days, we experience weather that we have previously experienced. And so the weather forecast is pretty reliable, and we can quantify how reliable it is. But then when we're talking about assumption-driven models, that includes pretty much anything with a social component. So I've included voting, elections in here, things like, energy mixes in 2100 obviously is very much a function of politics and society, as well as just projecting forward today's trends. I've put a picture of the coronavirus in here as well, because I think that on the, maybe on the short time scales, that's data driven, because the infections over the next week or so are baked into the cake of people's activity over the last week or so. But if you want to predict what the future of the pandemic will be in, say, 6 months' time, then you're talking again about things where you have to make very strong assumptions about what's happening and how people will behave in the future. So that is quite a lot more difficult. Okay, so next slide, please. Then that brings us on to thinking about the role of values and value judgments in models. So if we go to the next slide, and that's back to the example that I've already shown of the pandemic again. I think this raises a number of ethical questions which are relevant for modelers and for decision makers. So next slide again, just click forward one. The ethical judgments such as whose judgments are represented in these models. So if we say, this is a model of the coronavirus pandemic, but it was developed actually, years before the pandemic, and it was developed with the intention of informing pandemic influenza threat. And it was developed by a set of people in a certain environment and with certain sort of policy questions informing their development of this model, and with a set of computational and scientific constraints as well. So how did they decide what to represent and what not to represent? How did they make that decision? And what were the kind of decision factors impinging on that? Who decides what kind of things are politically feasible, in terms of presenting options and pathways? How do you decide that you're going to represent these kind of policy options and not others? You could think of ridiculous ones, which obviously, you wouldn't want to put into a model, but who sort of decides where the cutoff is? And maybe more sort of nuanced questions about exactly how you represent this and how you communicate it and what kind of lines you draw in which places. I think there are a whole load of questions here that are raised about these choices, which amount to ethical choices, and which then, as I said before, influence the debate and influence the policy discussion and ultimately influence the kinds of actions that are taken. And so if we go to the next slide, maybe an example which is more familiar to this kind of audience, if we're thinking about policy pathways for energy. So this is a set of, on the left, 6 integrated assessment models suggesting the energy mix in a baseline scenario for 2100. And then on the right, the same set of 6 models and scenarios which meet the Paris target of 2 degrees. So this is RCP 2.6. And you can see, firstly, that these 6 models don't agree with each other. They put different emphasis on different things because they price things differently. Essentially, if we make different assumptions about the cost of different technologies, then we will get different answers. So far, so obvious. And if you just go forward one again, it raises the same sets of ethical questions of who is making these judgments about prices, costs of technologies. How are we sort of defining the limits of where those costs go? What politically feasible options are? What is technically feasible and technologically feasible? What kinds of how do we sort of define the limits of technological feasibility when we're projecting forward 50 or 100 years? And what kind of value judgments come in there as well? If we, for example, decide to include behavior change, what kind of price do we put on behavior change relative to cost reductions in technologies? If we put behavior change in and say that it has a very high cost, then of course it won't happen. If we don't put it in, we're assuming an infinite cost of behavior change. And if we put it in and say that it has a very low cost, then of course we'd start doing lots of behavior change instead of making use of these other technologies. And so you can see that at the first order, there is a huge effect of the choices that we make and the assumptions that we make into the output of these models. And so again, the dialogue there is sort of two-way, and it's a sort of social thinking process of the scientist going away and making a model and coming back and saying, well, here's the output. And then maybe a policymaker coming back and saying, well, have you thought about this? Have you thought about that? Put that in. We can't put that in. Or do you think it's technically feasible? Or has anyone else thought of this? So I think there's a whole load of interesting questions there. And if we go forward again then to the next slide, then I think this raises questions about diversity of models. So I showed 6 models there. And if we go to the next slide, here are a set of 7 models. So this is just a sort of thought experiment, but supposing we have 7 models and that here they are, they're 7 cats, and we look at them and we want to infer something about the unknown reality out there. Well, models, of course, tend to look like each other because they're modeling something which is real. So you hope that they look like each other. If they didn't, you'd be a bit surprised. But what are you going to do with these models? So we could then go out and take a measurement of reality. We want to calibrate our models. We want to check them against the real world. So we say, maybe we go out and take a measurement and we find a piece of fur, perhaps a tail, and we come back with it and we start comparing it against the models that we have, these cats here. Are we going to throw away the ones that are the wrong color? Are we going to throw away the ones that have the fur is the wrong length? Are we going to throw away, perhaps we end up throwing away all of them if we do something like that? Or are we going to take maybe the 3 of them that are the best and then average them? Or are we going to weight them in some way according to how accurate they were? Or are we going to take all of them and use all of them to construct a range and then communicate that range, perhaps? We could do any of those things. And all of those are common practice in different areas of, the use and communication of models and multi-model ensembles is what we call them when you have a set of models. But let's skip to the next slide and see what reality looks like. Okay, so here's reality, and reality is not a cat, it's a dog. So what am I saying here? I'm saying that often our models are sort of overconfident. They are more like each other than they are like reality. And I think that will hopefully feel familiar to many of you. So what can we do? If we don't think that we can get a confidence interval about reality by taking the range of cats the dog is not within the range of cats. What would we have to do to get reality to be kind of within the set of candidate models in a useful sense, you know, in a sense that we could actually do some statistics? Well, what we need is more diversity. So if you go on to the next slide, we need to push out the boundaries of the model and be able to say, well, actually, we're not just trying to get the best possible cat. We accept that our model is a cat and it's not a dog and it's not reality and it will never be reality. And actually part of the purpose of modeling is to make something which is simplified. It's not reality because actually if we had another version of reality, it would be just as inaccessible as the current version of reality. We need something simple. So it is still a strength. But we want to say that we can't take inferences directly from this set of cats to learn something about the dog. And it is worth saying that we can learn quite a lot about the dog from the cats. You know, they do have similar sorts of behaviors. They eat similar sorts of things. If you were a veterinarian who was trained on that set of cats, you'd probably have a pretty good shot at solving something that was wrong with the dog, but not perfect. So how do we get more diversity in models? My contention is that to get more diversity in models and to get the appropriate amount of diversity in models, we need to see more diversity in modelers, so the people that are doing modeling. And that's an argument that I expand on more in the book and we could talk more about. But if we go to the next slide, please. Really the key takeaway here is that mathematical models are social objects, and they are kind of impinged on from many directions. You know, there are scientific constraints. There's obviously the constraint of reality, which is the thing that we're trying to model. But then there are also the assumptions that we make, which are very much framed by the backgrounds that we have as modelers, you know, and we might come from many modelers come from very typical sort of white middle class backgrounds, and we have certain sets of experiences and we don't have other kinds of experiences, and so we have blind spots and biases. And again, that, you know, that is another argument for why we should be improving the diversity of the modeling environment in such a way that we can then improve the diversity of models. Yeah, so I think I'll stop there because I know that there are lots of questions that Normand and James have, and we will come to your questions as well. But thank you very much, and look forward to it.
Thank you very much, Erica. Thanks for a very nice presentation. We have indeed a lot of questions, and plus those will be coming from the public. So if you have questions, you can write them in the question box, and at the end of this presentation, we'll take some of these questions. I would like first to let James Meadowcroft start the discussion. That's what we are driving. It's not a debate, or so you can start, James.
Great, thank you, Normand. Well, firstly, Erica, let me say how much I enjoyed your book. I actually got it like within a few days of it being released, because I can't remember where I saw it, but I just saw the title and said, I need to escape. And so I was, you know, very, very much enjoyed reading it. There's so much of interest in it, and I'd urge people to go out and get it and read it. So I just wanted to share a little experience I had in the last couple of weeks and kind of get your reaction, because it feeds right into your thing about model land and the real world and inputs and outputs and assumptions. So I was hearing a presentation someone was making about their model results of what the world would look like in 2050 when we've got to net zero. And they described a little bit about the modeling exercise, and they commented at the end, well, you'll notice that there's quite a big section of direct air capture incorporated in the output. I can't remember the figure, but maybe it was a third or 30% of the emissions in 2050 end up getting mopped up by direct air capture. And then the person went on to explain, well, you've got to understand a bit how the model works. Once we did everything else we could possibly do, direct air capture was the cheapest thing that was left to since we had to drive it to net zero. And then the presentation went on and we had some discussion. Somebody then asked a question about, your model seems very general. How is it useful? What does it tell us that can help policymakers? And then the person said, well, the model is useful and we get lots of conclusions. For example, we see how important direct air capture is if we're going to look forward in a world in 2050. But at the moment, government investment in direct air capture is hardly present at all. So it seems to me there's something really problematic about that when modelers kind of get trapped in the results, which are actually in some way a product of the input. So I just wondered,
completely, yeah,
if you had any other examples, or if you could just talk about that kind of a problem.
Yeah,
because I think
I think it's a
common.
great example. Yeah, I think it's really common. It's yeah, I think and it's so there's the direct air capture. I mean, and there's also the example I mentioned with behavior change, whether we put behavior change into these models or not. And it's an assumption, and it's also a value judgment, right? And so the same goes for the direct air capture. If you put it in and assume that the cost is low, then it will happen a lot in the model. And if you put it in and the price is high, then it won't happen at all. And there's no point reporting that, because you're just getting out what you put in. It's completely circular. So I guess the question then is, what else does this apply to? Where else are we just getting out the assumptions that we put in? What value is the model actually adding here? And I think there are other things as well where this is going to become an option, an issue, such as, if I dare mention something, the controversial like geoengineering. If we don't put that into the model, then it is not included as an output. As soon as somebody starts putting it into a model, it will be included as an output. And where do we put the price point for something like that? I think we're on this kind of treadmill where we were planning for emissions reductions, and that didn't really happen. So we go to carbon capture and storage, and that didn't really happen. And so we go to direct air capture, and is that going to happen? And what do we go to next? Do we go to is geoengineering kind of the next step in this sort of forcing the models to give us the output that we insist that it must have? And if we are in that way kind of torturing the models to give us the answer that we want, what does it then imply for policy making? The policymakers, I think, should resist being pushed in this way by the models and by the modelers, and start asking more searching questions.
And that's a very good, example of this. What you call the assumption driven. So it's not data really, because you have to project a lot of scenarios in the future just to get things started.
Yeah, so we need to be more clear about the assumptions. And then I think, if you say actually the model is kind of by the by, and the model, all right, it is useful because it allows you to sort of sanity check some of your assumptions and say, well, if this, then that, and if this, then something else. And that is useful. So I'm absolutely not saying that the models don't have value. I think they also have value in that sense that I was describing as a boundary object and as a sort of a facilitator of communication. And that's incredibly valuable because it helps different audiences with different kind of levels of technical expertise speak to each other with the model as that kind of mediator. But if you can set aside the model for a minute and say, well, what assumptions have we actually made here, and where do those assumptions come from, and have we consulted widely enough to have confidence in these assumptions, and what are the assumptions that we're sort of forced to make because we can't even think about how to model these other things? So behavior change, for example, if we say actually we just have no idea how to model human decision-making processes, and so we don't put behavior change into the model at all, then we're effectively allocating it a sort of infinite price point.
And great. So going back to this, because this gets back to what you said in starting. Model can limit the debate. And you said maybe we can expand it by diversity. But in some way, the diversity, the way you're describing it, it's kind of helping the hypothesis and the scenarios. But there's also the structures of the models. Aspects that in some way, people who can dive into this will have a similar training, because we have and these models will have been developed not over 2 years or 3 years. This is kind of building on orientations, decisions taken 40 years ago or 50 years ago that were piling up. I mean, codes last forever in spite of what we think. So do you see a way of measuring this? Are there ways to say, okay, I cannot change that, but I can at least identify boundaries to be aware of that? Is there a...
I mean, so I suppose I'm more familiar with the physical climate modeling side of things, and we have the same issue. You know, the code lasts forever, and the sort of the cause of these models are, you know, Fortran, written in the 1970s, and you know, I think you don't need to throw away the big models that have developed over a long time. I think you have to sort of go back and say, what else can we supplement that with? Are there complementary models that we could construct in different ways, perhaps less computationally intensive, you know, perhaps ones which are taking an approach which comes at it just from some kind of different angle. And so I don't know how that would work exactly in energy systems modeling. I could imagine sort of innovative and imaginative ways of doing it that would start perhaps from a, you know, just transition perspective. And you say, well, if we want a just transition, what are the key pillars of a just transition? And can we sort of model those, perhaps not even in a particularly quantitative way, and putting those together and saying, well, then what does that look like? And I don't know. I mean, I don't know what it looks like, because I am not the expert in this topic, and I'm not the person to ask. But you could go out and you could find who is the person to ask, and you could make something like that happen. But when all of the funding and all of the excitement and all of the prestige goes into these big fancy models that have taken a long time to develop, and they've done in the main a good job of answering the kind of policy questions that are being asked, then I think you just have to take a step back and say, well, could it have blind spots, and where might they be, and who might help us find the angle that lets us see the other side as well?
Erica, you've kind of touched upon, you didn't exactly use those words, but the trade-offs between complexity and simplicity. And you also referred both to mathematical models, but also other kind of conceptual models, or models that are not so. So I think those things are quite important maybe to, you know, elaborate on a little bit, because most people think models are these enormous big things that only consultants or, you know, people with massive computing resources that they take hours to run. But there is, you know, there is a bit of a trade-off, because with these long-standing models, the people who've developed them originally may have retired. They're pieces which may be black boxes, even for the people working on the models, because they've, you know, it's so complicated. Yeah. Nobody can quite figure out why it gives this output when you put this in. And I've talked to colleagues lately who said, well, we know we have to get it through the model, because otherwise the government won't sign off on the thing. So we tweak, we find other things to fiddle till it will spit out what we need to do. And then we go and say, look, the model says it's okay. Well, there's something, like, for a layperson, there's something weird about that. And talking to some colleagues in Europe, they've emphasized that very often a much more stripped down simple model is both easier to communicate to politicians, stakeholders, and even keep straight in your own head what's driving what. So I just wondered if you agreed.
Yeah.
And what you...
Yeah, I mean, I do agree. I think we need a sort of hierarchy of models where you say, well, you know, here is the sort of absolute fundamentals of the situation, and can we gain anything from that? And in climate science, that would be the greenhouse effect. And you say there is, you know, the Earth is a ball floating in space, and it has an atmosphere, and there's some radiation coming in and there's some radiation going out, and how does it change when we change the radiative properties of the atmosphere? And bang, you know, that tells you almost as much as you need to know, actually, for a whole lot of decisions, you know, for one set of decisions. and then you say, well, how much further do we need to go? What kind of information do we want to get out of it? So I think there is a question of what kind of models are fit for what kinds of purposes. So a very simple model may be fit for the purpose of communication, of kind of insights, of developing confidence in the basics. But then, of course, if somebody comes and says, well, I want to know how much the sea level is going to rise in the Thames estuary in order to be able to work out what to do with the Thames barrier, that is not any use at all. You've got to do something more there. You know, you can say in general terms it's going to go up. Okay, the start. But you need a different kind of model to answer that kind of question. And then you say, what kind of model do I need? Well, it has to represent the things that are important here for this decision. So you have a conversation with the policymaker about what they are interested in, and a conversation with the scientist about what can reasonably go in, and then you can do it. And then you have to say, do I actually believe the information that's coming out the other end, or is it just, you know, garbage in, garbage out? Do I have enough here to be able to say that I have some confidence in it? And so I think that's a key point, because you can go away and make your model and it'll spit out anything. Who knows? How are you as the modeler going to sit there with some credibility in front of a decision maker and say, yes, I believe, I personally, me with my professional credibility on the line, believe that this model is telling you something which is useful enough for the purpose of informing your decision. And that's quite a difficult one. And that's one that, I think, there's an idea maybe that models are sort of objective and that they tell us the objective truth. And of course, this is completely wrong. They don't. They are social objects. And they have no value until somebody makes a claim that model tells you something about reality, until you actually escape from model land. So the onus is really on the modeler to be able to say, yes, I believe that this model is useful. It's useful in the following ways. I can quantify my uncertainty, or maybe I can say, how confident I am in the output being reasonable. What probability would I put on something completely different happening? That's useful. And then, okay, that might be an awkward conversation to have, but that provides genuinely useful information for the decision maker. Well, now you come to a slightly different question, which is, what is the incentive for the decision maker? And is the decision maker, in fact, looking to make the best possible decision, or is the decision maker looking to sort of cover their own behind? Are we looking to find a number that will justify a decision, or are we looking to genuinely inform the decision? I think there's loads of interesting questions there. Again, about that sort of interface between science and policy, and how it works, and what the incentives are exactly on each side, and what each party expects to get out of the process. I find that really endlessly fascinating, and different case studies in different kinds of areas.
Yeah, I mean, that puts a lot of pressure on both sides, and the user of models too. One of the aspects, maybe if I go back to a technical questions more, but you've been involved a lot in climate modeling, where backcasting somehow is a way to establish that you're moving forward and validating some of the models. This is much harder to apply, for example, when you look at technological models, where backcasting doesn't tell you much about the future. So, yeah. I mean, how would you approach this in the various questions you've been looking at, the value of backcasting, or how to integrate that?
Yeah, so I mean, again, this comes down to expert judgment. So the modeler will have to say to what extent they think that past performance is a warrant of future success. And that's difficult, right? That involves you taking a step out of model land, because you can't answer that question with respect to data. You can only say, I expect that future conditions are enough like past conditions to be able to get something out of this. And so the modeler is also going out on a limb. They're making a statement which is sort of difficult for a scientist, because scientists are kind of trained to be objective and state the facts, and actually we're in interesting ground when we start doing models, because models contain so much of ourselves in addition to the data and the reality that we're trying to model. So yes, the question was about whether the when we're going into that assumption-driven regime, how do we sort of justify ourselves?
Yes.
Yeah. Well, it's hard. I mean, in a fundamental philosophical sense, we can't justify ourselves. I don't know that the laws of physics are going to be the same tomorrow as they are today, but I have a very strong confidence that they will. You know, I feel pretty sure that tomorrow gravity will still go down and that these kind of things will still work. I'm highly confident in that, and we all agree. But I'm less highly confident when I talk about technological development or political attitudes or how people think and value different things, or, you know, what will happen to exchange rates. All of those things are much more difficult. And so, again, it's a question of saying, you know, is this an assumption that any reasonable person would agree with and having some kind of evidence to back that up? Or is it an assumption that people coming perhaps from different perspectives might disagree with for certain reasons, and then trying to analyze those? And of course, there's always the possibility of a black swan, you know, something genuinely coming out of nowhere and being blindsided by something that nobody could have expected. But you know, the majority of things that we, you know, get told are black swans, so the pandemic or the financial crisis, you know, these are not things that were in principle unpredictable, and they were not things that were unpredicted if you looked in the right places. So I think that we can, if we again put that emphasis on diversity, and that sort of diversity of perspectives coming to the modeling process, we can have a degree of confidence in saying, this is an assumption which we feel confident in, and here is another assumption that we feel less confident in. We can put some evidence behind it. But ultimately, it is always going to be unjustified. You know, I cannot tell you that the laws of physics are going to be the same tomorrow as they are today.
Normand, can I ask another question?
Yeah, go ahead.
Yeah, so I wondered something about how we communicate with the public, but also you touched a little bit on communicating with decision makers about models and what they tell us and their strengths and their limitations. I mean, every model presentation that I've been, the modeler starts by saying, well, this is a model, we made many assumptions. Of course, we can't read out. And then it's kind of almost like the prayer at the beginning of a meal or something. Then you forget about it once you're actually into the dinner. And I'm wondering, there's a huge tendency to roll out models to prove things like, we've modeled this and Canada will be more prosperous at this point, or there'll be X 100,000 more jobs if we do this than we do. And I'm just wondering, how should we use them in communicating with the public? Or if you had advice about how to do it better.
Okay, I mean, that's a big question.
It is a big question.
It depends. I think it depends very much on what kind of model it is. I mean, so there are the kind of things like flatten the curve, I think, was a really good example of a model being used to communicate with the public, because it was really completely stripped down to the essentials. You know, you don't even need to know what the numbers are or what's on the axes. You just say it's like this, and then it would be like that if we did this, and that's better, full stop. So it depends on the degree to which your model is capable of any kind of simplification without losing the essential message. And in many cases, it might not be. It depends on the sort of relative sophistication of the audience that you're trying to communicate with. And for some, you know, you may be able to present actually a really complicated model. And if you go through it carefully, you can show, if we change this, you get that, and if we change this, you get this. And people make nice visualizations and things that I think there are some really nice implementations, for example, of sort of policy relevant models where you might provide a slider or something, and you can say, if we change these different parameters, you get these different answers. But having done that, there's, as you say, there's that meta level question of, well, do you actually trust it? And I think that's something that you can only really communicate in conversation. I think that's something where you need to have that relationship between the modeler and the decision maker, for the decision maker to be able to ask searching questions, and for the modeler to feel comfortable to be able to say, well, there are these assumptions, and not just kind of blanket it all with that caveat that it's only a model anyway, because I think there's a economic modeler, Paul Fleiderer, who has described this kind of model as a chameleon model, where when it's perhaps applying for funding or trying to claim policy relevance, then the assumptions are sort of all just caveated to one side and we won't even think about them. But when somebody comes back and says, this was wrong, or I disagree, or you made the wrong decision on the basis of this model, then they'll say, oh no, only a model, we had very clear caveats, you shouldn't have used it for that. But that's not really acceptable, is it, to do both of those? You have to come down one way or the other. Either your model is fit for the purpose of informing a decision to the best of your ability, and you accept that this isn't going to be perfect, or it's not, in which case don't sell it as if it was. And I think there's fault on both sides of decision makers sort of maybe having a bit of wishful thinking about models, what models could do for them, and hoping to be able to get a nice clear answer, and also sort of wishful thinking and disingenuousness perhaps on the side of the scientists who say, well, here's the model, and sort of just let it be used without necessarily talking too much about the assumptions. Yeah, it's a tricky one. I mean, it's not the way that science is set up, really, that we sort of expect science to be able to go out, do the modeling, provide the answer, here you go, and then it's just a sort of linear question of communicating more effectively for the decision maker to be able to make best use of that information. And I just think it's not at all like that in practice. And
so you've been working also, I mean, we talked a lot about the policymakers, but you've also been working with the private sectors and other groups. I mean, do you find there's a difference in the approach to modeling, or is kind of it's fairly similar?
No, I think it's fairly similar, actually. I wouldn't say I've identified a big difference between public, private sector, or third sector as well. But there are very different levels of sophistication, but that's really more a function of the application area. In finance, they tend to be highly quantitative. The humanitarians perhaps tend to be less quantitative, and it's that shouldn't in principle be a problem. I think there are different levels at which you can kind of interact, but I think if they know what kind of questions to ask and they are sort of aware of the limitations of the models, then it doesn't really matter. You don't need to be a great expert. If you get your phone out of your pocket and look at the weather forecast, you don't need to understand the details of how the weather forecast works, and you don't need to go and look up lots of scientific papers, but you do understand that tomorrow's weather forecast is probably pretty good. The forecast for the weekend is reasonable. And the forecast for 3 weeks' time is going to be so bad and contain so little information that you wouldn't look at it even if they provided it. So, even the most sort of untechnically sophisticated users can have a clear understanding of the limits of models if they are communicated effectively.
Thank you. I think we'll have to stop this discussion now, because it's 5 to the hour, to let some people. So I'll take some questions from the public. So thanks you, James, for the discussion. One of the questions, I'll go through some of those because we have about 10 to 15 minutes. So how do we deal? I mean, this overconfidence with respect to modeling, we raised it. I mean, clearly when somebody comes up and gives a contract and say, I want to have this number, I mean, there's some limited capacity to kill this overconfidence from people who want to use this data to support. Is this about education? How do you do this? Can we do it can we reduce this overconfidence on a one-by-one basis, or it's more about general education?
I think it's more about general education. It's also about modelers not overselling too much. I think that sometimes there's a bit of a tacit agreement that the modelers would like to oversell the models, and the the recipients of the models would kind of like to overbuy, in a sense. They want to have the number because they want to be able to put the number in a box to show that they've done their due diligence, and it doesn't really matter what the number is. That again, it's not so much about getting the right answer as having an answer, any answer. So that is tricky. But if we assume that everybody sort of is working from the best possible incentives and motivations, then I think, yes, it is just a question of a little bit more education and a little bit more just sort of thinking around the question of what is it that models can do and what they can't do for us, and being realistic about that. And I hope that, that's one of the things that my book contributes, that I wrote it with the aim of being accessible to a wide audience, and with the aim of giving the less technical stakeholders in the modeling process some language and concepts with which to sort of grasp these technical questions and start to ask more searching questions of the modelers and the modeling process, and to sort of understand how to do that in a way that helps them to understand the level of decision relevance that a model has, rather than just having to accept what's sort of thrown over the fence sometimes.
And another ask, in fact, coming back to what you're discussing about diversity, if you want a diversity of models, that also means you have a lot of diversity in the assumptions and in the way you assemble the models in some way. After that, it becomes extremely hard to compare and to say, okay, this gives me this number, but it's not only the data that changes, it's hypothesis and all this. So how do I make sense if I multiply these models to address the diversity questions that you're putting in?
Yeah, I mean, well, you can't do a statistical analysis, but you couldn't do a statistical analysis anyway. That's the point. The point of the cats and the dog is to say that actually it doesn't make sense to do the statistical analysis on the models that you do think are the same. And so if we introduce a set of other models which make maybe completely different assumptions and maybe have very different sets of inputs and outputs, all right, yes, you can't do the same kinds of statistical analysis over that set of models. But I think that's not a problem. That's actually a strength, because it means that you aren't lulled into a false sense of security of trying to do something that wasn't actually formally applicable to begin with. Is that a reasonable answer, or is that too controversial?
Yeah, no, I think that's a good answer. There are, if you, again, in this discussion, somebody else, I've seen a lot of comments where all find that you're, fantastic presentation. About, again, this kind of cat and cat, what about, I mean, the models will represent some physics. Often you have kind of techno-economic models. You have a mixture of physics, in which we know something pretty certainly. There's economic models that have some diverse value. So how do you, I mean, when you get answers from these models that come in with very different level of certainty, or at least fundamental assumptions, how do you measure the outcome of that?
Yeah. So some models are better than others. Yes. I mean, this
but
is
even they are
true.
often integrated.
Yeah, absolutely. The question is sort of, how do we ensure that our set of models is not just cats, because that's going to be overconfident. So we start including the pig and the tiger and the fox, and then it gets better. How do we ensure that we're not including a seagull and a crocodile and a llama? How do we sort of have enough diversity but not too much? How do we ensure that we are open-minded but not so open-minded that our brains fall out and we don't know anything? That's really difficult. That's a question of expert judgment, professional judgment, and of sort of having a process which sort of defines what kinds of information are useful and valid to describe that situation. And so this is a question of, how does science work, right? It's a question of how do we decide to work together in a way that will kind of constrain the uncertainty range, but not too much. And I'm not sure exactly how you do that. I think that it's a social question. And I think we have to sort of beware that I think we have, in general, in many areas of science, gone too far in one direction by saying that, these big complex models that use the maximum computational power and the most sophisticated methods and the largest amount of input data, and that are produced at elite institutions and people have all got letters after their names, and that these must be the best models. And we have ended up in a situation of effective groupthink, that the models are too close to each other. We've got a set of cats that are far too close to each other, and they are diverging from reality, which is a dog, or maybe it's something else. And so I'm just saying that we need to kind of go in the opposite direction a bit. And yes, there's a danger of going too far in the opposite direction, but we're not there yet.
So, related to this, I mean, there's been debates in Canada about, should we have a single model, say, for to model the energy transition, a common base that would simplify the discussion between elected officials with the company, with the public and all this, so that you don't confuse with numbers and projection? Or is it better to have a diversity and understanding that that means you can have opposite answers that will then make it more difficult to have models? So it's really about how do you use models for communication, but that's also the reality of how you make politics. So what's your take on this?
I think it's really helpful to have a common core, a common basis, which everybody sort of understands and expects to be able to see, and understands the assumptions that went into that one. And then you have sort of common data, common formats, and you can plot things on the same axes and be able to compare them. There is a huge benefit in that, obviously. And so I wouldn't say that we shouldn't do that. But I think it is helpful to complement that with a wider diversity as well. And I think you also have to say, well, what is the purpose? Are there multiple purposes here, or is there a single purpose? Because if there is genuinely a single purpose, then there could be a single best model. And in which case you might want to go for that. But if you're trying to fulfill multiple purposes, informing the decision and communicating the decision are potentially two quite different purposes. And then there may be multiple decisions and multiple stakeholders that you want to communicate to, and they might all need different kinds of models to do that most effectively. So, I mean, I've just sort of skipped the question by saying it depends on the situation. You may find it worthwhile going more one way or more the other way.
And as we move with more and more artificial intelligence model, like ChatGPT and all this, which are also models in themselves. I mean, are we gaining understanding of models, or do you feel that that might bring us to more trusting models more blindly because
I'm glad we came to the AI
of these models?
It's a difficult one because I suppose the way I think about it is that if we are in the data-driven regime where the data that we have from the past are relevant for the future and we're really confident about that, then the AI can do incredibly well. And so we can let our machine learning loose on all of our data, and it can go ahead and do whatever it likes. And I don't think, if we are pinned back to the data, actually, I don't think the explainability is particularly important. We can just go ahead and hopefully it will in some way reduce the amount of computational power. It will let us answer different kind of questions. It might find clever ways of doing things. And that's exciting. And it's a really big opportunity. So, AI has its place there. But then when we come to the assumption-driven regime, when we're going outside the realm of the previous data and we think that actually the assumptions that we make are going to be the first order important in terms of determining the outcomes, then I think we have to be extremely careful about using machine learning methods. I think that we have to be really careful, for example, with the way in which the values are built into them. So, for example, machine learning methods tend to work with some kind of objective function. Well, what are they trying to minimize? That is effectively your goal, and that's familiar, for example, from cost optimization models, where you say, well, what's the least cost pathway to 2100? Well, by doing that, you're saying that the only thing that matters is the financial cost and nothing else matters. You know, all of these other social things and the intangibles and the sort of community impacts, none of those matter at all unless we can happen to put a dollar value on them and put them into this single scalar thing to be optimized. Well, I think there's a danger of AI and machine learning models taking that, you know, putting that on steroids and saying, well, let's, you know, just optimize something that we haven't even necessarily worked out what it is that we're optimizing, because it's built into some automatic function in some package that we don't fully understand. I think that's extremely dangerous. And
on this really questions, there's another question that comes up about the implicit ethical implications of the models and how, I mean, those are hidden and they are in every model we use. And is there, what's your take on how we can communicate this better, on how we can extract this better?
I think we just have to start talking about it. I think we have to be more transparent about assumptions and also think more carefully about what those assumptions imply. You know, think about if you've made a model which disaggregates people by age and gender and social class versus if you've made a model that assumes that all people are the same, for example. You know, that is an obvious one. And if you look, for example, at the you know, that influenza model pre-COVID, there's a nice animation from the Nature paper where it was published, and it showed that the you know, the infection was sort of seeded in different places, and then it would just sort of bubble up and then down again. And so essentially the map was just a map of population density, and it just increased and then decreased. And of course, that's not at all what we saw during the pandemic. It would increase in one place and then another place and then another place in patterns that had a huge amount to do with you know, demographics and socioeconomic status and all of these sorts of things. And those were not really considered in the models and clearly important. So I think those kind of blind spots are where we have to interrogate the model closely. And again, diversity is a way of doing that, that if we have diverse perspectives being brought to bear on the model, then they can start asking, what about this? What about that? In a way that is just hard to do when you've been brought up in a particular group and you understand how it works and you're familiar with it and you're familiar with all the assumptions and everybody just kind of works through it. You know, bringing in different people to do the criticism, I think, is helpful.
And we're running out of time also. I'll ask you the last questions. We're talked about a lot about the uncertainty and different models, but we're also spend a lot of time when we build models getting the right assumptions and getting the right data. Again, I mean, and often we don't run that many scenarios around. So, I mean, is there a way to get around easily, if you wish to include some diversity, to spend much more time into scenarios instead of getting all the data right? Or what's your, how do you see that?
Yeah, I mean, scenarios are good, I think, generally, and we can use them to represent things that we can't necessarily directly represent in the model. So, I mean, yes, it's a question of resource. Where are you going to put your time? Where are you going to put the effort? Where are you going to put the funding? I mean, again, it depends on the application, but often taking data is a good investment because you will have that data for a long time. But do we expect the data to continue to be relevant or not? Again, I may sort of skip the question by saying it depends. It's very much dependent on the area of application and the kind of decision that you're trying to inform. You might find that it makes sense to spend a huge amount of time on the data, and actually that's the main thing. You might find it makes more sense to put all of your effort into scenarios and actually maybe not do any modeling at all. That might be a more effective use of time, but it very much depends on the context. I'm not going to come down on either side on that one.
Thank you. So just as we leave, what will you be working? What are your main questions you want to address over the next few years?
Oh, wow. That's a huge question. I don't know. I suppose I'm working on the mathematical methods for escaping from model land and thinking about actually, you know, what are the quantitative methods that we can use, and what are some guidelines for best practice in terms of escaping from model land and making statements which are genuinely about the real world rather than about models. And then also, I mean, the other strand of my research, I guess, is thinking about how that interfaces with the decision maker community, and how people actually use this kind of information in practice, and how it feeds through.
Erica Thompson, thank you very much. I remind the people that you are an associate professor of modeling for decision making at the University College London, and author of a book that I also strongly recommend, Escape from Model Land: How Mathematical Models Can Lead Us Astray and What Can We Do About It. I would also like to thank James Meadowcroft, who is from the professor at the School of Public Policy and Administration at Carleton University. Thank you to all the organizations who supported this, the Transition Accelerator, the Energy Modeling Hub, and the LEADS program. Thank you to all of you for being present today. You can see the links for the next webinars coming from modeling courses and other courses that are offered at the Transition Accelerator. Visit also the other websites from the Energy Modeling Hub and LEADS. So thank you very much. Thank you again, Erica and James, for this fascinating discussion. And hopefully modeling will play a better role and more appropriate role in the coming years. Thank you very much.
Thank you so much, and thanks for having me.
Bye-bye.